the thing we are going to learn under complex number. In our complex number, we are going to be learning some series of topics that matters in our exam. Those topics are those things that will come out. So what I did in my studies is I ensure that those topics are what matters compared to what you are going to see in your exam. Please, I need your rapt attention. So let's start. Outline. The first thing we are going to learn under this complex number is we are going to learn the introduction to complex number. Moivre Theorem. So this everything, every single thing you should know under complex number. Every single thing. And this thing are set in your exam. So let's start. The introduction, please. What is complex number, right? What is complex number? Complex number can be defined as a mixture. We are writing. Complex number can be defined as a mixture of real numbers and imaginary numbers. Complex number can be defined as a mixture of real numbers and imaginary. Now, symbolize. The symbol for a complex number is z equals to a plus ib, where z is called the complex number, where a is referred to as a real part, where I is the imaginary, and where B is the imaginary number. This is just the introduction to what is complex number. Like I said, mixture of two things. What's first thing? Real numbers and what? Imaginary numbers. So like I said that where we have our z is what? A complex number. Why this A is called a real part? Why this I itself is called imaginary? Then when you use that B, is that what? So let's give a quick example. Let us know I said z is equals to 2 plus I3. Who can tell me where is the real part? So the way they write it is like this. They say RE as real of the complex number is what? 2. Now, what does this RE stand for? Real number. Then when you use the word ING for the complex number is what? 3. So who can tell me? Our 2 is what? Our 3 is what? Is that clear? Now the question is, what does this I, this imaginary number, how did they get it? What is it? How do they form it? So let's look at this example. Look at this. Example. Let's assume we have x squared minus 1 for the first one, and we have x squared plus 1. And I'm asked to find the value of x. So look at this carefully. Solution. I have the first one, x squared minus 1. I want to get my x. What will I do first? I can bring minus 1 to the other side. So I have it as x squared equals to 1. Because here it was minus. Crossing over to what? Plus. You get it? But the goal is to find x, isn't it? So what will I do? Square root both sides. When I square root both sides, what do you observe? The square root cancel what? Square. We're left with what? X equals to square root of plus or minus. This is a quadratic equation. Do you know that? Because if I should do it this way, I can also write it like this. Pay attention. I can say x squared minus 1 squared, isn't it? Then it leads to what? X minus 1, x plus 1 equals to 0. When you equate the two to what we have, x minus 1 equals to 0, x plus 1 equals to 0. Then we have that x here is what? 1, x here is what? The same thing is applicable here. When I square root the both sides, here is plus 1 and what? So I can say my s is what? Plus root of what? 1. Then what? Minus what? Root of 1. Who can tell me what will be the answer to this? S is what? Plus 1. Or the root of 1 is the same thing as what? You get what I'm doing now? Is it simple? Very simple. Now let's see how we can simplify this one. Let's see how we can simplify this. I'm working with time. So let's look at the other one, which is B. The other one we have it as x squared plus 1, isn't it? Now we can equate it to what? 0. So what will I do? I have that x squared equals to 0 minus 1, isn't it? So I have that x squared equals to minus 1. What will I do? Square root the both sides, isn't it? When I square root the both sides, you see that the square will cancel out the square. We are left with that s is equals to the square root of plus or minus 1. Is that not it? So what will I have here? I will say my x is equals to what? Plus square root of minus 1 or minus square root of minus 1. Are you paying attention, please? So look at this issue. Can I find the square root of minus 1? But can we find the square root of 1? Yes. But can we find the square root of minus 1? So anytime you have a situation whereby, okay, who can tell me why can't we find the square root of minus 1? Because of the minus sign. So due to because of that, we cannot simplify it. They call it complex number. Is that clear? So there's a way we can manipulate this. This place I have square root of minus 1. Can it be written like square root of minus 1 times square root of 1? Yes. Because you know in solve, when you have square root of a multiplied by what? Square root of b. What will it give me? Square root of ab. So it's not the same thing here. So when I say minus 1 times 1, what will it give me? So this place that I have square root of minus 1, we call it imaginary number. See, square root of minus 1 is symbolized as, they use either I or J, either of the two symbols. So what will I do here? What will I put here? Or J. So let's pick I for our own case. So I'm using I multiplied by, what is this? So what's the root of 1, everyone? That's 1. 1 times I is now what? I. You see that? So can I say that my x, can I say that this place I have x equals to plus root of minus 1 or minus root of minus 1? Hence, I can say that s is equals to I or minus I. Are we correct? Because we said this is what? High. So this is what? High, isn't it? So what do I have here? What do I have here? So here is plus, here is what? Minus. So that's what we call imaginary number. That's how they got the value of what we call high. Is that clear? So let's solve another example. Yeah, morning. Another example. Okay, example 2. Let's simplify this quadratic equation. It says 5x squared minus 6x plus 5 equals to 0. Now, using formula method, who can remind me what's the formula method for quadratic? S equals to minus b plus or minus all the square root b squared minus 4 is. 2a. Had it been I was taking quadratic and symmetry, it's very important. I would have taught you how you can derive this. But let's leave that aside. Where do I, at this side, where is my a? A is 5. What's my b? Minus 6. What's my c? Plus 5, isn't it? So any place we have our b, what will we put there? Now, if you look at this b, it has minus before. So we have it as minus, in bracket, minus 6 plus or minus, isn't it? All the square root of what? Minus 6 all squared minus 4 times, what's your a? 5. Then our c is what? 5. Okay. Can we put in bracket? All over what? 2 times 5. Can you see from there? Are you managing? So we can tell what will happen here. S equals to what? Plus 6. Sorry, not b. Plus or minus all the square root 36, because minus 6 times minus 6 is plus. Plus 36 minus 100 over 10. Thank you. So what will happen at the long run? Minus 64. So that means we have it as 6 plus or minus, then minus 64 over what? 10. Now we are at the junction now. Is there a way we can separate this by saying our x is equals to 6 plus square root of minus 64 over 10, or 6 minus square root of minus 64 over 10? Do you know what happened there? This place we have plus and minus have separated. So one is now plus, the other is now minus. Is that clear? Who can tell what's the issue? Can we find the square root of minus 64? But can it be written this way? We can say s equals to 6 plus, that place we have that, can we say square root of minus 1 times square root of 64 all over 10? Or the same thing applicable to this 6, then square root of minus 1 times square root of 64 all over 10. Is it possible that way? Yeah. So what will I have? S equals to 6 plus, what's this thing for everyone? Very good. Recall that root minus 1 is I. So that means S is equals to 6 plus I times 8. Can you see now? Over what? 10, or minus, that's 6 minus I times 8 over 10. Then I have it as S equals to 6 plus I times 8 is what? 8I. But that's wrong. You don't forget, I gave you the format. The format is, when we say the complex number is A plus IB, you must ensure that the I come first before the B. The I should what? So what's going on here? I should come first. I8. I8 or over 10. Or what is this? 6 minus I8 over 10. You can't leave your answer this way. What can you do? You can separate it. 6 over 10, isn't it? Plus I8 over what? 10. Can you see that? Because when you look for the LCM, you are still going to go back to this. Or the other one, 6 over 10 minus I8 over what? 10. So who can tell me, when you divide 6 divided by 10, what we have? Or in decimal point? Thank you. In decimal point, we are going to have it as what? X equals to 0.6 plus what? I is 0.8. Or the other one is what? 0.6 minus I is 0.8. So this part is called what? The real part. Why this part is called what? Please, this question can come out in your objective. Now, let me ask a very quick question. This part is what? Real part, isn't it? Then this part is what? The imaginary part. Let me ask a question. Please, who can tell me? At this side, what's my imaginary number? is 0.8. At that other side, what's my imaginary number? Minus 0.8, because here is what? And the symbol they use for imaginary number, like I told you, IMG. For we part, RE, in case you see it in objective. Any questions so far? Can we go on? Please write. Okay, now, let's go. The power of imaginary number. The power of imaginary. So there are two powers in imaginary. We have the first one. We have the positive integers. And we have the negative integers. So let's do a quick example. Are you with me, everyone? Now, recall that I said that our I represents what? Look at square root of minus 1. So if my I is squared, pay attention. If my I is squared, are you with me? And I have here to be what? I have that my I is square root of what? Minus 1. So in that case, I can say square root of minus 1 all squared. Do you agree to that? Remember that my I is square root of minus 1. So when I say I squared, I can literally say square root of minus 1 all squared. What will happen to the square root? It cancels out. Then I'm left with that. Put that in mind. Okay? Look at this case. What if I have I in the power of 3? This I in the power of 3, can it be written like this? I in the power of 2 multiplied by I. Don't forget that this I in the power of 1. And that's 1. I in the power of 2. Now look at this case. I in the power of 2, then 1. What law is that? Indices. It says that when you have A squared, then A. You can put here as 1. That's A2 plus 1. A in the power of 3. It's not the same thing here. But remember that this your I square is what? Minus 1. So what will I have? I3 is now what? Minus I. Is that clear? Put that in mind. What if I have my I in the power of 4? How can I write it? I can say I square all the square root of what? All the square, isn't it? If you remember, 2 times 2 is what? It's not the same thing here. And remember that my I square is what? Minus 1. So when I put here, that makes I in the power of 4 equals to minus 1 all squared. That will be what? 1. Is that clear? Can I come again? Let me come again. Recall, we said imaginary numbers are what? Square root of what? Minus 1. Yes or no? So what if we try to square it? When I square it, don't forget that my I is square root of minus 1. Putting it in bracket, applying your square, the square will cancel out the square root. We'll be left with just what? Minus 1. That is being done. Let's consider this one also. I in the power of 3. This I in the power of 3 can be written as I in the power of 2 multiplied by I in the power of 1. I told you that if you use the law of indices, what happened here? A in the power of 2 multiplied by A in the power of 1. They have the same base, you add the powers. Adding the powers, you have it as the same thing we have here. So because of that, I told you that this I in the power of 2 is said by saying what? Minus 1. So if you say it's minus 1 times the I, that's why we call it minus I. Is that clear? If you come to this case, this I in the power of 4. This I in the power of 4, we can write it like this, I squared all squared. Because 2 times 2 is 4. And remember that your I square itself is minus 1. So when I put here as minus 1, that means minus 1 times minus 1 is 1. So please, I need you to pay attention. Keep these things. 1, 2, 3, okay, then 4. Because we are going to use it to do other powers. Let's give an example. Sample 1. Find the value of the following. The first one, I in the power of 12, I in the power of 23, I in the power of 50, so how do you solve it? Solution. The first one we have is what? I in the power of what? 12, which is the first one. Who can tell me? Do you know I can write my I in the power of 12 to be I 4 multiplied by I in the power of 3? Are we not correct? Are you sure? Why is it not correct? If I should do it this way, what will I have? 7. So how should I write it? I in the power of 4, then what? 3. Very good. If you should do it this way, you're having your power to be 7. But if you should do it this way, what will be the power? 12. So remember that my I in the power of 4 is what? So that means I will say 1 in the power of 3 is same thing as what? That's the answer. Always use your I in the power of 4 to find the factor for all these ones. Okay, let's try B. Looking at B, we have I in the power of 23. So how many multiples of I in the power of 4 can I see in 23? How many multiples of it? Are you sure? That's I in the power of 4 in the bracket of what? 5. Then multiply by what? Remember that 4 times 5 is 20. 20 plus 3, 23. The balance. So since we already know the value of I in the power of 4 to be what? To be 1. So I will say here is 1 times I in the power of what? Recall that I in the power of 3 is what? Minus I. So what's the answer? 1 times minus I. Answer is what? Minus I. Everybody try 50. Minus 1. Very good. Let's see others. Try 50. Please, if you don't understand anything, you can ask a question. There's something about me. You would like tell me to go back, I can go back. Thousands of times. Minus 1. Okay. This place. What do you say? I is power 3. The value for it is here. Minus I. It's minus I. We are using the answer as I. What happened is that, pay attention. What happened is that this I in the power of 3, we first splitted it. That means we are using the multiples of 4. You got, okay. For compared to number 1. No. Okay, no. What happened here that here was I in the power of 4. Here is I in the power of 3. It's two different things. Here that's I in the power of 4. It means 1, which is my I in power of 4, in the power of 3. That's 1. That was why it is 1. But if it was, what is going on here? Look at what's going on here now. Here is I in the power of 3. It's standing alone. That was why I was telling you to memorize this. When your I is 3, it's going to give you what? Minus I. When your I is 2, it's going to give you what? Minus 1. When you have only just one I, answer is what? Square root of minus 1. Is that clear? But when you have I in the power of 4, that's what? 1. On the option, very good. So that's how you have it as minus I when I have I in the power of 3. Is that clear? So let's try C. Can we try C? Can I clean this side? Here now we have I in the power of what? 50. What's the first thing you do? Look at 4. How many multiples of 4 can you see in 50? How do I get it? No, but you don't. Eh? How do I get it?
This one is this.
Yes.
This one is this.
Yes. So what happened that we all know this thing is called imaginary numbers. So instead of writing it as square root of -1, we leave it as this,
Just
like this. So it should have written like square root of -1, but it's not necessary. Since you know that our imaginary number is what? I. You are still correct if we should put this thing there. -1 times this, but it's same as saying -1 times I. So I have it as minus I.
Okay.
Yeah. So, like I said, we said we have I in the power of what? 4 in bracket what? 12. 4 times 12, everyone. 48. Then I what? Square. Recall that I in the power of 4 is 1. So 112, then I square. What will I have here? I square. And I square is given as what? -1. That's the answer. Not -1, I, -1. -1. It's minus I, -1. So let's go to the next one. The negative integer. What if we are given a negative integer? Can I clean this side? I have to be very fast. A negative integer. What we are given a negative integer? Okay. Are you with me? Recall, please. Hey, it's low. It's not C, it's I. It's I or J, not C. Alpha. It is power bank. Can I finish class? Let me just finish aspect of charge it. Sorry, my guy. So now pay attention. Recall, hello, please, the board. Recall that I square is equals to what? -1. Pay attention. And I want to get the value of what? I. Hello? What I want to get? When I is going to be what? -1. The other time, what's my I the other time? I was just 1, isn't it? So this integer, is it negative or positive? This integer, is it negative or positive? So that's why they call one positive integer when your I is what? A positive integer. And I thought so I can go about that. But when your I is a negative integer, how will you do about this? So what's the first thing? Now look at this case carefully. Can we divide both sides? I want to get this I in the power of -1 from here. Can I divide both sides by I? When I divide both sides by I, what happens? I will cancel I. I'll be left with what? 1I here, isn't it? So that means that 1I is equals to -1 over what? Now this -1 over I, can it be written in form of inverse law? Remember that we say minus A in the power of -1 can be written as 1 over A. So at this case, we can apply that same thing. We can say I is equals to -1 minus, it's not the same thing? Yes. Because this -1, this is it. Then this inverse law for this is it. What's my target? I want to get the value of what? I equals to -1. Is it there now? Is it there now? So what will I do? Divide both sides by I. So it's there. So we have it as I equals to -1, then the I -1. So dividing both sides by -1, it cancels out this. So I have that the negative integers of imaginary numbers is minus. Is that clear? Okay, let me come again. Recall, I said that the first thing we have is what? Negative integers and what? Positive integers. And I try to differentiate between what a negative. He's making this call. Okay, thank you. Thank you very much. So when we have our negative integer, how do we know this is a negative integer? Because the power is what? Minus. How do we know this is a positive integer? Because the power is what? Plus. When you see the power to be minus, it's called a negative integer. When you see the power to be plus, it's called a positive integer. So let's look at this. I said, let us see how we can get a negative integer, which is I in the power of what? Minus 1. And I said recall, from our I in the power of 2, from the positive integer is equals to what? Minus 1. If I should try to divide both sides by I, one I will cancel one I, we'll be left with one I at this side, equals to minus 1 over what? I. So this is what we had. So the next thing I did is that this thing is obeying inverse law in indices, which says that if we have anything like a in the power of minus 1, it can be written as 1 over a. So look at what's going on here. This side, okay, you know what I'll do? Let me try to separate it so we can understand better. Can it be written this way? This is I equals to minus 1 over 1 multiplied by 1 over I. Isn't it? Because minus 1 times 1 will give me what? Minus 1. I times 1 times I will give me what? Which is the same thing. So this one is like this. From here to this side. That's what I'm going to do here. So I can write it like, let me come here. Let me clean this side. I can write it by saying my I is equals to minus 1 divided by 1. Minus 1 divided by 1 is minus 1. Multiply by what I said here. I raised to power what? So when you say minus 1 times this, so divide both sides by what? Minus 1. So we cancel out this minus 1. So my I minus 1 is equals to minus j. Because I divided by minus 1 will give you what? Minus j. Is that clear? So this is the negative integer. Minus I, Jesus. Sorry, j. Minus I. So I minus 1 equals to minus I, not minus j. Please, in my textbook, I use j. So I want to use I. So can we go on? Is it clear now? So let's try to find the value when I is minus 2, when I is minus 3, when I is minus 4. We want to find the value when I is minus 2, when I is minus 3, and when I is minus 4. Okay, can we pay attention, please? Can we write this thing like this? Pay attention. Can it be written like this? This first one, can I say I minus 1 in bracket 2? Because when we say minus 1 times 2 will give me what? And recall, this minus I, which is here, is what? So when you put it there, we say minus I all squared. And that's what? It's not the same thing? I. It's just I, sorry. Is it clear? Are we correct? It's I squared, have you? Let me confirm, please. Yeah, it's correct. It's I squared. You know that here is square, Abby? Pay attention. Hello. Calm down, calm down. I'm the one teaching. I'm the one teaching. I'm the one teaching. I'm the one teaching. So here should be what? You know, this can be written as minus I times what? Minus times minus. I times I, isn't it? But recall, in the positive integer, I squared is known as what? Isn't it? So that's it. Let's see this case. How can I write this now? Indices, try to form indices. Here is what? I minus 1, isn't it? Can we do it this way? Come in. I minus 1 multiplied by I minus 2. No or yes? Because in indices, -1 plus -2. -1 plus -2. -1 -2, Abi? I minus, are we not correct? So what's the value of when our I is -1? -2. What's the value when my I is -1? Very good. So what will I have? Minus I, isn't it? Multiply by what? -1. What's the answer? I. It's not simple. Just learn the derivation, because all these things you can simply put it to your mind. But I'm just sure you can derive them. Let's come to this case. Can this one be written as -I minus 2, Abi? Yes. Then the power of what? 2. Because when we say -2 times 2, that will give us -4. And recall that -I in the power of -2 is what? So I can say -1 all square, which is what? So please put this in mind. Any place I see my I to be -2, what will I have? Any place I see my I to be -3, what will I have? I. Any place I see my I to be -4, what will I have? 1. These are the things you should put in mind. So let's solve question. Let's solve question. Let's assume sample 1. Find the value of the following. Find the value of the following. When I is -13. When I is -24. When I is -60. When I is -13, I is -24, I is -60. Let's do that fast, no time. Now the goal is, look at it. Which of these negative integers is the perfect one to use as a factor? When I is -4, isn't it? Because we have it as 1. So because of that, I can say here should be what? I -4 in the power of what? Because 4 times 3 is what? And I'm left with how many? I minus. Do you get what I'm doing? -4 times 3, -12. Then you have to have -1 left. So what will be the answer? Okay, what's the value for this? 1. So 1 in the power of 3. Then, so this is your answer, please. Answer is what? What's -1i? -I. That's how you solve it. Let's try this case. Okay. No, you can't bring the 3 in. If you bring the 3, you are right. But you are going to make use of this. When I is when I is -3 equals to I. But it's advisable that I use this one because of the factor of 1 to make it faster with you. So let's consider this case. Let me just have the board, please. Can you see from there? Small, please. I'm sorry that I'm blocking you. Or I'm backing you. So I -24. In the multiples of -4, what will it be? I -4. Then what do we have? 6. Recall that I -4 is what? Is 1. So 1 in the power of what? 6. What's the answer? Is that simple? Is it simple? Everybody try this. 1. Okay. Well, let's try this. I think the one is simple. Let's try a big one. Can I have this side? Have you tried this one? So how do you get it? I in the power of what? 15. Because 4 times 15 will give you what? And recall, I in the power of -4 is what? 1 in the power of 15. And that is as simple as ABC.